Again, good morning to one and all. So, this is Ayyappa Srinivasan, Assistant Professor Triple E of St. Mother Teresa Engineering College. Today in ECE, EMF, EC 345 electromagnetic fields, we are going to discuss the topic on gradient, divergence, curl, as well as certain theorems related to them and their applications. So this is our these are all the topics that we will discuss today. So gradient. First of all, let us go for gradient. What is gradient? Maximum space rate of change of a scalar is called as gradient. For this, you can you can say example of any road, particularly that you might have gone through in your place, Thuthukudi or Tirunelveli. So, where in certain places, especially in places near to hillocks, the road will come down or it will go up. So, the height of the road changes in space with a particular rate. Say this much of height per length. So this is called as gradient. So the gradient can be given by del, and the del is given as dou by dou x ax vector plus dou by dou y ay vector plus dou by dou z az vector. So in three direction, how the gradient how the particular quantity, that is in our example it is height of the road, changes is given in this. So dou by here near this dou we have to add the ax, right? We have to add our vectors, right? So we have to add the vector that such as ax, ay or az. Likewise, in the that is in our cylindrical coordinate system, it is given by dou by dou rho a rho vector plus 1 by rho dou by dou phi a phi vector plus dou by dou z a z vector. Likewise, how a cylinder changes while moving from its height or some radius may change. So how does it change? From while moving from bottom to top is the gradient in cylindrical coordinates. The same way it goes with spherical coordinates. Dou by dou r ar vector plus dou by dou phi ay vector plus dou by 1 by r dou by dou theta a theta vector plus 1 by r sin theta dou by dou phi a phi vector, because the spherical coordinates are given in r, theta and phi. Now let us consider the next important topic, that is divergence. Divergence is nothing but you can have a pipe through which water comes out and if you catch the pipe with the hole from which the water comes out with your thumb and index finger, the water will spray it away. The water will be what? Sprayed away. So I hope you may understand, the water will be sprayed away, that is in a divergent manner. So it will be in a divergent manner, water will be flowing around various directions, up, down, left, right and in between directions too. So it is sprayed away. So such an incident is called the example for divergence. So you can see the same thing in the definition. Divergence of a vector A is the amount of outflow of flux from a closed surface. From a closed surface, the vector outflows in various directions, that the outflow is taken per unit volume. So that is the important thing. The outflow of the water or flux, whatever may be, it is taken in per unit volume. As the volume shrinks to 0, the volume reduces to 0. So, in Cartesian coordinates, it is given as del dot A, dou AX by dou X plus dou AY by dou Y plus dou AZ by dou Z. In cylindrical coordinate, it is given as 1 by rho, dou by dou rho, rho A rho plus 1 by rho, dou A phi by dou phi plus dou Az by what? Dou Z. Next, in spherical coordinates, it is given by 1 by r, dou r a r by dou r by dou r plus dou a phi by dou phi plus dou Az by dou Z. This is the divergence formula. Now, let us go to another important thing, that is curl, right? That we are going to take it as curl. In curl, what we find in curl is the curl is the curl of a vector is the whose magnitude is net circulation per unit area. That is, if we rotate a string by taking it in our hand, the spring will rotate. The spring will rotate in the space. Such a rotation is called as curl. So, how much direction, how much distance it circulates in the space per unit area as the area shrinks to 0 is called as curl. So, the Cartesian coordinates curl is given as dou by dou x ax vector plus dou by dou y ay vector plus dou by dou z az vector. But in cylindrical coordinates, it is given as dou by dou rho a rho vector plus 1 by rho dou by dou by a phi vector plus dou by dou z az vector. Whereas in spherical coordinates, it is given as dou by dou r ar vector plus 1 by dou r dou 1 by r dou by dou theta a theta vector plus 1 by r sin theta dou by dou phi a phi vector. So, we have seen three important properties: gradient, divergence and curl, right? So, now our attention is focused to divergence theorem. Before that, you have to note one thing, that is the divergence of a vector yields scalar. That is, the output of divergence operation is a quantity that has no direction but it has only magnitude. But the output of the curl as well as gradient gives a vector. Please note, this is most important. So, let us go for another concept called divergence theorem. The theorem states that the volume integral of divergence of a vector taken over a volume is equal to surface integral of that vector taken over the surface surrounding the volume. So, first you have to understand what is line integral, surface integral, volume integral of a quantity. Nothing but take line integral, a point is there anywhere. Now, if you are taking the line integral means you have to take the values of that point projected over the particular line. Projection in Tamil VL. So projection you might have studied in your 12th standard. So take the projections of the point on the line and their values. Add these values, you will get what? The line integral. Like this is the physical meaning. Likewise, surface integral means take a point and find its projection over a particular surface and find the magnitude of those projections, and these sum up will give you the surface integral. This the same goes with volume integral. So volume integral of a vector v del dot v dv is equal to v dot ds, that is surface integral of that vector taken over closed surface enclosed by the volume. Likewise, Stokes' theorem. This theorem states that the surface integral of curl of a vector. Take a curl of the vector, and the curl of the vector, if you make the surface integral of that vector around the closed path of that surface, it is equal to line integral of the vector of that vector over the surface. If you take surface integral of curl of a vector, right, curl of a vector over a surface, right, this will be equal to line integral of the vector in a closed path on the same surface. So surface integral del cross B, that is curl of a vector over a surface ds is equal to line integral B of the same vector over a line. That's why we have given us dl. Then these are all the important theorems, and we will see the problems based on this in our next video. Okay, thank you.